So everybody has their prints. You don't have your prints. Justin is getting them, and he's pulling his four out, and he will bring yours, or he'll throw the stack to you, and you can get yours. I'm going to go ahead and open up some of the drawings that we have here. So this is going to be, this is really your final project. We have essentially 20 days of school left of this first 8 weeks, which will happen very, very fast. So if you are done with everything, this is your next progression of projects. This will bring us culmination of all the things that we've done, and then the addition of bringing the mill into it. So this is the part when you get done with it. It is a dead blow hammer, or essentially a dead blow hammer. So this head of this thing is brass. The body is aluminum. The nut you don't have to make, it's a purchase. So it's a flange nut that goes on the end of this. The difficult part on this part is a couple of things. One, it's the alignment of two counterbores. You just got done doing counterbores on your vice jaw. And then there's a keyway that you're gonna have to mill into it, and then you'll also have to broach inside of this. So this is the handle. You're gonna turn this on the lathe. You're gonna do some threads. You're gonna do the head, and then we'll be done with it. So you should have the prints in front of you. So I'm gonna go through those. So this is the handle of the part. We're going to start with some 1-inch diameter by slightly over 9 inches long piece of aluminum, okay? You're going to turn it, knurl it, turn this side down, turn this down, and then thread it. Here's how I would make this part. I would turn this diameter back at least 4.6. I'd probably turn it 5 inches back. I would chamfer it, and then that's all I would do to it, okay, on that side. I would not knurl it yet. I'd say that for my very last operation. The reason why I would do this side first is if you accidentally undersize this, you can make it this side. See what I'm saying? So you're building in opportunities to fix a mistake. I'm not going to give you unlimited amounts of pieces of material for this, because oftentimes we get, oh man, I just messed up, I need another piece. Oh man, I just messed up, I need another piece. And you get, next thing you know, you got like a factory of half done wrong parts. And like the idea is that I think I can get it right by just doing it wrong a whole bunch of times, that I'll actually do it double wrong and somehow make it right, and I'll just accidentally make it right. So the idea is that we stick this part out of our chuck on our 3-jaw or 4-jaw chuck. We face it off, we put a small center in the end of it, we turn the diameter down on it, we chamfer it, we then flip it around and chuck on this part of it, okay? We'll chuck on this part of it, we want that thing to be running true and concentric. We're gonna center this in, we're going to turn this diameter down, and then we are going to turn this diameter down, and this is 1/2-13, okay? It's gonna be 1.5 inches long here. The threads go back 3/4 of an inch. The threads can go back further than 3/4 of an inch. They just can't really go back less than 3/4 of an inch, okay? So it'll be a 1/2 inch diameter back, this 1.5 inches. And then this diameter is 750 thousandths, so 3/4 of an inch in diameter, okay? You get an overall length. Taking the overall minus 4.6 tells you how long this section is. Subtract 1.5 inches from that, you know how much the remainder here is, okay? Chamfering on both ends of it. That's going to be done with a tool that I'll give you when you're ready for that. I know Justin, he's ready for it. Skylar, he's ready for it. A couple of you guys are. That's going to be a tool that comes to a point, but that point is 30 degrees, okay? So that point's like this. But what this is asking for is 45 degrees. So with that tool being 30 degrees like this, I'm asking you to turn it 15 degrees so that you can get 45 degrees. That is just, it's nothing super complicated. It's just you looking at it, turning it 15 degrees, grabbing your protractor, eyeballing it to 15 degrees. So it's going to sit in the tool holder a little crooked, okay? So don't make that into some crazy math thing. That's just, I need it to look like it's about 45 degrees, just to chamfer it, just breaking the edges, okay? After you have done everything on this, you will then chuck up on this diameter in a collet. You'll have this already centered, you'll knurl it at the end. Everybody's done knurling, yes? Everybody's done some turning, right?
I haven't done knurling yet.
Okay, so you need to get yours knurled, your tap handle knurled. And, so you've done some turning, you've done some facing, you've done some centering. The only thing up till here you have not done is threading. Okay, I'm gonna show you a really simple, slick way to do threading. It's gonna be not single pointing. Single pointing is what we used to do in 101. We moved it to 102. So I'm gonna show you a really, really slick way to make some threads, and they'll come out just gold. Okay. So there's that. Now I guess let's just talk while we're here about the milling of this. We just, in 101, we just barely touch on the mill. You're going to mill this keyway. This is an 1/8 inch keyway. And typically I would say this is not the way I want you to make a keyway or any kind of milling operation, but in this particular instance, it will be fine. We're gonna take an 1/8 inch end mill. We are going to mill this slot stepping down in the center. I'm gonna show you how to use an edge finder, how to square vise, and do those kind of things. We'll mill that slot with an 1/8 inch end mill. It will oversize slightly. Then we'll put our 1/8 inch key in there. It'll be fine. All we need to do is keep it from spinning. Okay. Cool thing about this is you have a brass head that you'll make. If you have time, you can make a plastic, like a Delrin head for it. You can make a steel head for it, and then you just replace the heads of the hammer. So the handle's always good, and so if you beat the end of this head to death, just replace it and put a new head on it, and so it's good again. All right, so let's look at the next print. I think this is the one that we're on now. Open. This is the head of the print, or this is the head of the part. One of those sheets that I've given you is really just the keyway information. We'll cover that whenever we get to it. This is a piece of 1.5 inch brass. This is really probably the most expensive part that you'll work on. It's about $3 of brass. It's not $1 million, but with 10 students, if each student makes 3 or 4 of them, you end up with quite a bit of money spent on it. So I'm gonna give you one piece. Be gentle in making this. You don't have to take big cuts on it. I'm asking you to take 50 thousandths off the outside of it. Again, chamfering it both ways. And so what I would do is I would take it and I would bring it out of the chuck. I would turn it to 1.45. I would chamfer this in. I would part this off. If you haven't parted off, I'll show you how to do that. And then you can even chamfer it before you part it off. And then once you flip it around, face it off, it's done. This turning operation, super, super simple. Now we get to the through holes that go through there. One side of it is absolutely no problem. It is this side. You can drill it through, and you're gonna drill it through clearance for 1/2 13. So we can go, well, 505, that'll keep it nice. So we'll drill and ream it. You've already reamed 505 before. Then we'll do a counterbore here of 760, and so we'll use a reground end mill for that, and then 1 inch 20 for this side. So the problem that you come into with this part is the alignment of the second side. It's this drilled hole, this counterbore, easy money. Flipping it to the opposite side and getting it to align so that the hole is straight is gonna be the key. So what we'll do is when we drill this hole and we counterbore this, then we'll flip it upside down. We'll put a rod down in there. We'll make sure that rod is standing straight up, pull the rod out, and then we'll go back down through that hole, okay? So that's how, because if the hole's like this and the counterbore is like this, when the bolt head goes down on it, it won't sit down flat. And you'll find the hammerhead always coming off. The bolt will always be loosening up because the spot face it's just not on there enough, okay? The things that I'll provide you with is the aluminum for the handle, the brass for the head, the key for the keyway, and then the flange nut for the nut. Questions? What's your confidence level on this part, 1 through 10? How confident do you think that you are in making this part? 10?
I don't know if I'd say 10, because then I make one little mistake and I'm an idiot.
Yeah. Justin, what do you think?
I'll get a 9.8.
9.8.
I'll say like 8.
Okay.
7.5.
7.5, okay.
Might be 7.
What?
Might be 7.
7?
7.5.
7.5, okay, I think maybe somebody's like 7.3286 or something, so, okay, so most of these things are things that you have done that are similar, okay? So our goal is to always be drawing off of the previous parts that we've made, so we've done some drilling, we've done some reaming, we've done some turning, we've done some facing, we've done some knurling, all these things that we've done. This one just now kind of becomes like the big thing, okay? So you have this, that you'll work on for the next really 2 weeks, okay? During that 2 weeks, we will also take you down to the testing center and give you a NIMS test. We went through 25 questions, 30 questions of the NIMS test the other day. Hopefully you've already taken the practice NIMS test in immersive. It is a pretty good, realistic idea of what that test is. If you do not pass that test, it is 20% of the grade. Here's how the system works. If you get 80% on that test, that's a pass. Okay, if you get 50% on that test, it's not a pass. If you get 80% on that test, it's a pass. Then you get 80% of 20% added to your grade. Okay, so if you currently have an 80% in class and you get an 80% on that test, your grade will not go to 100%. Your grade would be 80% plus 80% of 20%, which is probably like 16%. Then you end up with 96% in the class. See what I'm saying? If you get 30%, and so here's why we do that. We used to say, we'll add 20% to your grade, and then that'll be your grade. But what we had were people who were not passing it, but still could pass the class. So we want you to get the certification, but we have people who would get 13% on the test. So we went ahead and instead of discounting them a full 20%, we said, we'll give you 20%, like 13% of that 20%, so that way they could still get like some points, and sometimes that was enough to flip them over into a C. If you don't have a C or higher, you can't move on, okay? So that was kind of a safety net for some people, and then they would go to the second 8 weeks and they were like, I need to retake that NIMS test. And we're like, okay, so they would go back and take the NIMS test and they did great. Sometimes you're just not quite ready for it, okay? Don't let that be the crutch. Don't be like, oh, I can take it as many times as I want. It can have a drastic effect on your grade, especially if your grade is like a 70% now. That's teetering on, I mean, that's below, that's really kind of at the bottom of the C level. If you get a below 20% on that, then you're gonna be down, you're gonna find yourself at like 50%. Not only will you not move on, but you just won't pass class. And then that affects GPA. GPA is really, really important, not only for scholarships. If your GPA is not 2.5 or higher, you will not graduate. And I know that lots of times you're like, I'm brand new, I'm not worried about that. I have had students get all the way to the end and have had a couple classes that were gen eds that they D through. They passed them all, but they just did D's throughout the time, pulled their GPA down to 1.7%, or 1.7 on the GPA scale, and they couldn't graduate. So they had actually completed all of their classes and passed all of their classes, but could not graduate. When you are getting ready to graduate and you find that out, that's a huge kick in the nuts. And so I don't want you to have that happen. So oftentimes, go to DegreeWorks, check your GPA, make sure everything's going good. If you're C or higher in all your classes, you will have nothing to worry about, okay? C's get degrees, right? Like just, that's an okay thing to live with, you know? You don't, I mean, everybody should try to be an A student, but C's are okay. D's will come back and haunt you. If you drop out of a class, please drop out of the class, withdraw from the class, do not stop coming to the class. That's an F. You wanna see a GPA go from 3 to 1.5, that's how it happens. So just don't do that, okay? So I'm just saying all of this because we are coming to a close of the first 8 weeks. And this is probably, if you just came out of high school, this is probably the fastest that you went through a class. 8 weeks, I mean, next thing you know, you're just like you started class and then somebody's going, hey, we got 2 more weeks of class, and you're going, what? And so like, we just move really fast. And so like, first semester is always a little discombobulating. So everybody's like, I can't believe the semester's over that fast, okay? And then next thing you know, the next day, you walk into the same classroom at the same time and it's a totally different class. And you're like, what is happening? So It's okay, the first semester is just a little confusing, you'll be fine. All right, we need to cover a couple of things in the book. We are in, this week, you can see all of your modules, okay? I know you could not see your modules earlier this week, but now you can. You've been doing the work. If you've been doing the immersive stuff, if you've got all your immersive stuff done, you've been doing the work. So don't be like, holy crap, we're 5 weeks into this and I don't think I've done anything right. If you've done the immersive, you've done the work, okay? So like if you haven't done the immersive, yeah, you're kind of screwed. But if you've done the immersive, then you're in great shape. So we are going to push on through. So this is the thing that we've been working on. We are going to move this to next week. So I'm going to give you a quiz on machinery handbook and micrometers just to verify that you can do those things. Those are just double checks for me and for you to make sure that you can do these. So the reason why it's important is that you can use the machinery handbook. You can use that's the book that's in your toolbox. You can use the calculator that's in your toolbox. You can use any kind of calculator. You can't use phone.
You can use it on the NIMS test, can't you?
Yeah, that's where I'm going. Yeah, you can use that calculator. You can use any kind of calculator on the NIMS test. You can use that machinery handbook on your NIMS test. You cannot use any other kind of book like a textbook, and you cannot use your phone. Has anybody ever been to the testing center before, taken a test at the testing center? Okay. It's like a compass test or like a GED test or like a placement test. And so we're gonna walk over there. They are very strict. You cannot wear a hat in there, which is crazy. You can only take with you when you go to that test, you can only take a piece of notebook paper, a blank piece of notebook paper, a machinery handbook, and a calculator. You cannot you can't have an Apple Watch or a smartwatch. You can't have a smartphone, and then you can't have any kind of phone in there. I don't give her a rotary dial. You don't even know what that is. You can't even have that kind of phone in there. Like you can't have nothing in there, okay, except for what I've talked about. And that, because we often talk about there's so much information, we just want you to be able to find the information. Like that's a kind of a hiccup when you're used to using the textbook, and now they're like, no, you can't use this book anymore. You can only use the machinery handbook. So we want to start to get ourselves familiarized with the machinery handbook. So the first test that you take, and so we will take lots of tests down there during your entire time here. That first test that you take will be like you will walk out of there with either a pass or fail, and you will just go, I'm not sure what happened. But like this is the encouragement. So Shay back there, Shay, how many NIMS tests have you taken? 2, 3?
Yeah, 4, 3.
3 or 4? Now it's no big deal, right?
Yeah.
First time was a little.
Oh yeah, that's what I thought.
Yeah, first time you're going down there going, oh my gosh. But by the time you get to where Shay's at, you're going, oh, yep, NIMS test, no big deal. You walk down there, you take the test, you walk out. No, it's no big deal. Okay. So those things become very, very simple for us to do. All right, we're going to go through the lathe, just looking at some stuff just in case we missed anything along the lathe. Pieces of the lathe, the headstock is where the spindle is located at. It controls how fast everything moves. We will be using everything on the lathe except for what's called the half nut. Half nut controls threading, and that's the only thing that we're not going to use. Any type of round part can be made on there, so that's pretty standard. This is your headstock design. You can run stock through the head, especially if you're parting a part off. So if you're turning a part and you want to just kind of knife it off, we'll use a part off tool. And so lots of times I'll use a long piece of stock, put it in the chuck, turn it, part it off, and then I've got the rest of my stuff to use. And you're welcome to do that as we do the brass. All right, so there's collets that go on there. They screw onto the headstock. We've looked at a couple of those things. Some machines are belt changers. Ours are all gear change, so no big deal. This is gear changing. These are the ways and the bed. These are hardened. They're induction hardened, so they're only hard on the outside. They're soft on the inside. They're like a Sour Patch Kid. So this is the tailstock here. Tailstock is also adjustable left and right, in and out. The carriage is the thing that moves forward and backward. That's what holds your tool, okay? So here we have, this is the carriage. It's also got on it the saddle. So the saddle lays over the lathe, over the bed. This is the compound and the cross slide. So what slides crossways is a cross slide. What has compound movement is called the compound. So most of these things are pretty self-explanatory once you start to know what they are. Our lathes have two different ways of knowing where you are. There's a digital readout that's up on top of the headstock. There is also a micrometer dial for both X and Z. Those are the only two axes that you're going to be working in, is X and Z on the lathe. Here's your compound. Compound and the cross slide are both held in by a gib. It's a tapered wedge. The more you screw it in, the tighter it gets to keep it from moving. We want to give it enough movement to slide back and forth with a little bit of lubricant, and then it should work good to go. These are the screws that are spinning or not spinning. This rack is what drives your carriage down or back. You have your lead screw, you have your feed rod. So those, some are engaged while you're threading, some are engaged while you're turning. Okay, so if you can't get your lathe to move, the carriage to move down, and neither one of these is spinning, go over here and one of your dials is not locked in. Okay, so just want to make sure that dial's locked in. Tailstock holds our long pieces in. It has an adjusting screw, so it goes in and out. Here's one thing that I want to just really caution you on the tailstock. Tailstock, for the most part, is pretty rigid, pretty simple, pretty self-explanatory. This quill, everything that goes into the tailstock is held in by a Morse taper. So everything's just locked in by taper fit. To unscrew it out of there, you unscrew the tailstock all the way back. The tailstock, or the center, or the drill chuck, or whatever will pop out. If you go too far one way or another, or if you extend this quill out too far, you will have problems where it comes off of the nut. Don't do this. Don't push it back and beat it with a hammer, because there's an Acme screw and it has a hard time engaging on there, and if you beat it back on, you'll chip the first thread on there, and then we have to take the whole thing apart, and then we have to start all over again. We have to rethread the nut on there. Huge pain in the butt, and we will just cuss you guys for the entire time. So if that happens, it's okay if it happens. I mean, it's better if it doesn't happen, but if it does happen, grab somebody and we can gently screw that thing back in, and then probably you won't do it again. Like, it's one of those things, like, once you know where too far is, you're like, oh, okay, I won't do that again. So make sure that you're asking. If you can't get that thing to just automatically screw back in there, grab somebody and let them help you put that back in. We measure the lathe by what it will cut diameter-wise, typically over the cross slide, and length between center to center on there. So that's typically how you're going to measure the lathe. There is also, we're not going to really cover this much, but there's a lathe gap that can be taken out in case you're doing really big parts. So the shop I came from, we did parts that were like 24 inch to 36 inch in diameter. So we had chucks. Like, our chucks on our lathes are about 12 inches, 10 to 12 inches in diameter. Ours are like 4 and 5 feet. So we did big parts. And so we needed like all the room in the world that we could do. Our parts were so big sometimes that we would have these lathe gaps out, and it would almost be rubbing. And we would have to take our carriage and our tool post and run a boring bar on the outside to be able to get to turn the outside of it. Sometimes literally, you were hanging on the back sides of these things to give it enough rigidity to do what it needed to do. Because we would always, I don't care what the job was, whether we had a piece of equipment to do it or not. Customer said, "Can you do this?" We're like, "Yes." And then we would be like, "How are we going to do this?" You know. But that's what you do when you're in business, and you depend on people to, you know, bring work to you, so you have work. So okay, that is oops, closed out of Canvas. Get that, I got 50 of them open. We'll go through just a couple of these. Some of these you can just look at on your own. That'll help keep us moving along. Let's see. Let's see what unit 2 is. Tool holding. Okay, let's look at those real quick. We'll just look at a couple of them. You have a forward jaw chuck. A forward jaw chuck is an independent scroll or independent chuck. Every jaw moves individually, so when you tighten one, it just moves the one. This is dependent. When you turn one of those, it's on a scroll, everything moves together. Same thing typically here. This is on a scroll, all 6 jaws move together. You can have chucks as little as 2 jaws, as many as probably 8 jaws on there if you want. There are chucks that are dependent, there are chucks that are independent, and then there are chucks that are independently dependent, okay? So they move on a scroll, but also each jaw moves individually if you need to fine tune it. So several different ways to do work holding. So here is a independent jaw. So it only controls the movement of that jaw. So when you spin that, that's all it moves. This has a scroll inside of it. When you spin one of these, all of them move. Indicating your part in is really critical to make sure that everything runs concentrically on the same center line. When you put a part in the lathe, just does raise water bottle, there is a tendency to chuck it up, to put an indicator on there, and to get it running true. And so here's the problem with that. It only runs true in this one spot. So you can have this happening. Crankshaft. So what you have to do is you have to hold that part out far enough that you can indicate this diameter and this diameter to make sure that everything's running true. Or you have to indicate a diameter and a shoulder or face. So perpendicular points, so face and diameter, that will cause it to run true. Diameter and diameter will cause it to run true. Face and face will not cause it to run true. And the single point on the diameter, it could be going like this, okay? Whenever you turn the spindle on, step back, take a look at it. Does it look like it's running true? So there's a huge tendency, especially as you start to get kind of behind on parts, because there really is another project I'd love to squeeze in if we could. Put it in, clamp it down, start turning on it. Flip it around, clamp it, turn the other side of it. And then when you get done, you've got this huge mismatch between the 2 diameters, and you're like, what the heck? The lathe's a piece of crap. No, maybe, but no, that's not the problem here. You did not get these 2 things running, and now they're going like this. It's like a cam, okay? So make sure that everything is running true. Now on the CNC lathes, it's a little harder to do that. We've got some different ways of doing that. Sometimes we'll work on a collet. You guys have already done a little bit of collet work, and that helps out. Several different kinds of collets, several different kinds of closers. All right. So let's keep on rolling. We'll do one more. And then I am going to see what 5 is. We'll skip 4 and see what 5 is. No. Let's go back to 4. All right. Cutting threads. We've talked a little bit about threading already. Major diameter, minor diameter, pitch diameter runs at the halfway through. Then also the pitch is high point to high point, low point to low point on the thread, okay? Almost all threads that we're gonna cut are gonna be 60-degree threads. They're either gonna be Unified National Coarse or Unified National Fine. they will all be standard threads. There will be no metric thread cutting in this time. You guys will not have, you will have to engage the half nut, but you will not have to do full single point threads. We're gonna ease you into threading. But those are major, minor, and pitch are definitely ones to remember, because I'm gonna ask you those types of things. On this thread, it's a half 13. What's the major diameter? What's the minor diameter? What's the pitch diameter of this? Okay. Also, how to figure threads per inch. If something is 16 threads per inch, the pitch of the thread is 1 divided by 16, and so that's 62 and a half. If the pitch is half 20, 1 divided by 20 is 50 thousandths. So the pitch is 50 thousandths. So it's just always just real simple calculator. 1 divided by the threads per inch. That'll tell you the pitch. When threads fit together, there should be clearance here and here. What is important to fit is the teeth need to engage in each other. That's why pitch diameter matters. If I have a bolt and I'm making it's half 13 and I accidentally undersize it down to 490, it will still work if my pitch diameter is right. I could probably go down to 480 and it would still function okay, because my engagement of my threads would be correct. Because I can still make it the pitch diameter right, just the OD would be too small. So that's how we save parts, right? So like, especially if you're working on a multi-diameter shaft that's 14 feet long, 12 foot in diameter, you don't get to one thread, jack it up, scrap the part and start over. You've got to figure out how to make it work. So we're always building in, how do I, even if I mess something up, how do I still save this part? So pitch diameter is how you do that. If pitch diameter is off, then you've got to go to somebody like Justin and say, hey, can you weld this up for me and rethread it? And that kind of sucks. It does happen. Threads typically have a single start. That means that they screw on from one single point, but they can have multiple points of starting. So double lead has 2, triple lead has 3, quadruple lead has 4. That'll actually make the thread screw or the nut screw down there 4 times faster if it's 4 lead thread, but it'll have about 25% of the engagement strength as it does that, because the threads start to go more like this. And as they go like that, they become less strong on there. Okay. We'll talk about that more as we go. This is really just high view on this. If you're cutting threads on your lathe, there is a chart that says 40 threads per inch, 13 threads per inch, 6 threads per inch. Have to follow those numbers on the chart or you will not create the appropriate set of threads. This is called a fish. So it'll help you figure out some thread stuff. We'll look at it out there. This is the half nut. Only time that you're ever going to use this lever on your lathe is when you're threading. So if you are getting confused by different levers that are on the lathe, if you engage this one, it will kick into the threads per inch that it's already set to and just rock it on down there. So you might set your feed rate to something else and then you engage the half nut and you're like, freaking lathe's broke. It doesn't do what it's supposed to do. Or it's already engaged and you turn the lathe on, it just starts taking off. Half nut's probably engaged. Okay. This lever, until told, is not a lever for you to be moving. Okay. So just stay away from it. Hopefully, if you've got everything set right, the screw for that isn't even turning and it's not even going to be an issue. When you start making your threads, use your pitch gauge, put some Dicom on there, do a real thin scratch across there just to make sure you're making the right threads, and then go in there after that. We'll stop there. So here's what I want you to do. We'll go back to module. This weekend, I know you have nothing to do except sleep in, watch cartoons, eat cereal, do whatever. No, I know you guys are busy. But there is a section 5, unit 1 quiz, a section 5, unit 2 quiz, a section 5, unit 3 quiz, a section 5, unit 4 quiz, a section 5, unit 5 quiz. And that's all of them. It's 5 quizzes. They come straight from book, yes.
Have there been more quizzes from the other modules that we haven't been able to see?
There was only immersive.
Okay.
Yeah, if you've been doing immersive, you're good, even though you couldn't see the modules. You're still doing it. Clint was just like, hey, you need to make sure you do this, and he thought you could see it, you just couldn't see it. Which if you've done your immersive, then you are right where you need to be. Today is the first time that we started in the book, okay? So 5 quizzes to do. Some of these have only a few questions. Some of them have lots of questions. Here's how I would do this. If you have dual monitors, or if you have 2 computers, I would pop up the PowerPoint, I would pop up the quiz, and I would go through there and look at the questions. So we're information gathering right now. I'm not expecting you to memorize these things. We're trying to bring some information into your life. So you don't have to go look at the PowerPoint and then go take the quiz. You can have the PowerPoint open while you take the quiz. That's totally fine to do, okay? We're just trying to get you to see some highlighting information that we have determined is important. 5 quizzes need to be done when we come back Monday, okay? I really think if you will sit down with this, this will probably take you less than an hour and a half to do this entire thing, okay? All right. Where is everybody at today? Justin, you're ready to start your hammer, right? Who else is done with their vice jaws? Great. If you are done with your vice jaws, go ahead and turn them in today, and I will take those. Everybody else needs to get caught up to the place where we're at. So everybody go to have their vice jaws done today? Yes, 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 yes. Okay, if vice jaws are done today, that is a beautiful thing. That puts us in a pretty good start point Monday. I tell you what, how long do you think that'll take you guys to finish up vice jaws?
I need to drill the 4 bigger holes. I drilled the through holes on every single one, but I gotta go back and do that. I finished the one in mine, and then